All right, today we are diving deep under the hood of something pretty incredible, an AI that can moderate video content. And I'm not talking about some theory or a research paper. No, this is a real-world production-grade system that can literally see, hear, and reason about what's going on in a video, all in pretty much real time.
But that brings up a huge question, right? Think about it for a second. How do you actually teach a machine to truly understand a video? To go way beyond just flagging a keyword or a simple image. How do you get it to grasp the context, the nuance, the whole story? That's the challenge, and that's exactly what we're going to unpack today.
So, here's our game plan. We'll kick things off with the overall blueprint of the AI. Then, we'll get into the nitty-gritty of how it turns a video into numbers, or vectors. After that, we'll see how it finds evidence to actually reason about the content. And finally, we'll wrap up with the production pipeline that makes this whole thing tick at scale.
All right, let's start with the 30,000-foot view. I want to stress this again. This is not some science fair project. This is a complete production-ready architecture built for the real world.
And what's so cool is that you can basically see the entire system's journey just by looking at this directory structure. Think of the services folder as the engine room. That's where the real magic happens. Extract, choose on the raw video. Embed creates its unique digital fingerprint. And RAG is the brain that does all the reasoning. Meanwhile, pipelines is like the factory foreman, automating the whole process, while app and serving are the front doors that open it up to the world.
So when a video comes in, it basically goes on a four-step journey. First, the system grabs the video and breaks it down into manageable chunks. Second, it creates what are called multimodal embeddings. Just think of them as super detailed digital fingerprints for both the sights and the sounds. Third, it finds the most relevant chunks based on what it's looking for. And finally, it uses that evidence to make a decision, to generate a verdict.
Okay, so let's get into the really cool part. How does an AI actually learn to see and hear? This is the absolute core of the process, where we turn raw pixels and sound waves into a language the machine understands, numbers, or, as we call them, vectors. First things first, the system needs ears. For that, it uses a model called Whisper. Its job is simple, but amazing. It listens to every single word spoken in the video and turns it into written text. This is the first crucial layer of understanding. And of course, if you have ears, you need eyes. That's the clip model. It looks at keyframes from the video, and for each one, it creates a long string of numbers, an embedding. This isn't just about colors and shapes. These numbers capture the actual meaning of what's in the image. And finally, we need a scribe. See, the text we got from Whisper is great for us humans, but the AI needs it in number form too. That's the BGE model's job. It takes that transcribed text and turns it into a powerful numerical embedding. So now we've got numbers for what the AI sees and numbers for what it hears. But here's where it all clicks. The real power, the real understanding, happens when you put these two things together. By combining the visual data from Clip and the text data from BGE, the AI suddenly gets the full picture. It's like going from watching a movie on mute to watching it with full surround sound. It's a complete experience. And you want to know what's just brilliant about this? The actual code that makes this happen is this simple. It's one line. It literally just takes the list of numbers for the image and the list of numbers for the text and smashes them together into one super embedding. This technique has a name. It's called late fusion, and it is beautifully simple.
Now, every single piece of this system was built with the real world in mind, which means making smart trade-offs. For instance, why use faster Whisper? Because it's 4 times faster, and in production, speed is king. Why only sample a few frames per second? It's a perfect balance between getting enough detail and not breaking the bank on cost. And why late fusion? Because it's way simpler and more flexible. You can swap out the vision model for a better one later without having to retrain the whole shebang.
Okay, so our AI has successfully translated the video into this rich, numerical language. Now what? Well, now it's time to play detective. This next phase is all about using those vectors to find the right evidence and make a final judgment.
The secret sauce here is a process called Retrieval Augmented Generation, or RAG for short. It's a fancy name, but the idea is simple. You're giving the AI an open book test. When a question comes in, it's also turned into an embedding. A vector database then instantly finds the video chunks that are most similar. And those chunks, both the images and the text, are handed over to the AI's brain as context so it can make an informed decision.
So the two key players in this act are Fast API, which is like the efficient balancer at the front door, managing all the requests, and the Qwen2 VL model. That is the brain of the operation. It's a true multimodal model, which means it can look at the pictures and read the text at the same time to come up with a really nuanced judgment.
And this is basically what the brain sees. It gets a prompt that looks like a case file. It says, okay, here's the query, and here is the context. And that context is filled with the actual video frames and the transcribed text it just retrieved. All the evidence it needs is laid out right there. Look, having a smart model is one thing, but making it work reliably, 24/7, at massive scale, that is a completely different ballgame. So let's talk about the production pipeline that makes this whole thing hum.
To keep everything running like a well-oiled machine, the system uses Apache Airflow. Think of Airflow as the conductor of an orchestra. It just points and says, okay, first you run the ingest task. As soon as that's done, you run the embed task. It's a simple, powerful way to automate the entire data assembly line.
So where does the AI model actually live? It's deployed using Kserve on top of Kubernetes. Now, all you really need to know is that this makes the whole thing incredibly scalable. If suddenly 1 million requests come in, the system just automatically spins up more copies of the model to handle the load. No sweat.
And you know the saying, you can't improve what you don't measure. That's where MLflow comes in. It's like the system's own performance tracker. It logs all the important metrics, accuracy, speed, you name it. It keeps track of every version of the model, and it manages the whole process of promoting a model from testing into the big leagues of production. It's absolutely crucial.
So, after all that, the big question, does it actually work? Let's do a quick lightning round of the results. First up, retrieval recall, 92%. That means when the system goes looking for evidence, it finds the right clip 92% of the time. That is rock solid.
Next, how accurate is the final decision? It clocks in with an F1 score of 0.87. For anyone who deals with machine learning, you know that's a fantastic number. It's not just finding the evidence, it's making the right call with it.
And finally, is it fast? The P99 latency is just 245 milliseconds. To put that in perspective, that's literally faster than the blink of an eye. So yes, it is absolutely fast enough for a real-time production system.
So there you have it. We've seen how to build an incredibly powerful tool for understanding and moderating video at a scale we could have only dreamed of a few years ago. It's efficient, it's accurate, it's ready for prime time. But building it leaves us with one final and pretty important question to chew on. This AI